Hello and welcome to another episode of Risky Business. So last time we were attempting to draw a line in Milton, and we didn't have spectacular success, as you can see. I have a lot of stuff turned off um, to try to simplify the problem, but we're not getting our line. So I'm thinking maybe it's because it is drawing and it's just we don't understand where we need to draw. And it might be the case that we're drawing off the screen. That's one idea I have. Otherwise, I have no idea what's wrong. Like maybe 1.0 represents transparent instead of opaque, but I'm pretty sure one is opaque because I believe it said in the documentation that one was default, and you wouldn't default it to transparent. That wouldn't make sense. So, but I also think that we maybe are really doing this in the wrong place. So I want to whiteboard out kind of what I'm thinking here. So let me comment this stuff out. And then we're going to re-enable all this stuff. Yeah, I was using the UB one before, but I changed it to 4F just when I was testing random stuff. But we're passing values between 0 and 1. Oh, the vertex call should be in the range -1 to 1. That would explain the problem. So let's give that a try. So we're gonna say in that case this is gonna be -1, and then we're gonna say 0.5, so it draws halfway up the screen. And then this one would be 1.0 and 0.5. And we have a line. You were correct, Serge. Thank you for that tip. But, oh, I guess 0.5 wouldn't be halfway, would it? It would be 0 because it's -1 to 1. I was thinking 0 to 1 for some reason. But that doesn't really matter. But like I was saying, I think we actually want to move these calls somewhere else. And I'm just going to whiteboard out what I'm thinking here. So let's open up our stream canvas. And so here's what I'm thinking. Whoops. So let's just go over here. So basically, let's say we have something like this. Or I guess that should be like this. Well, here, let's do it like this. Hello, Kingspar. Don't shake your head at me. So we are going to draw a pancake type of thing. And so basically what we have is this layer right here is the canvas. And then up here we have the GUI. And then over here, these are our layers. And so actually we have more than one layer, but for our purposes, we're only thinking about one layer because we don't use multiple layers when we're whiteboarding. So right now, we are drawing the line after the layers, but before the GUI. So like, if I move this canvas a little bit, you can see that the line draws on top. But I'm thinking really what we want is, like if you think about notebook paper, the lines don't appear above what you draw, obviously, right? When you're drawing, the lines appear below because you're drawing on top of the lines. So I'm thinking what we actually want is we want to just kind of insert a layer like right in here. And this is where we want to draw our paper. So I am going to move things around a little bit. So first of all, I want to take a look and see so this is GPU render canvas right here. And then this is GPU render. So here we do render canvas. And then where do we do... So here's render GUI. So where did we do the render layers stuff? Does that get called by render canvas? Or I guess when we do render canvas, I'm thinking of the canvas as just like the background color. But I guess technically we're thinking of the canvas as being all the layers, right? So here we're rendering each layer, it appears. Right? So we have layers and we have strokes and we're rendering all that stuff. So what I'm thinking we want to do is just say like in our GPU render function, after we render the canvas, we want to do our line. So let's just see if we copy and paste how that turns out. So here we are filling screen with layer texture. Well, I guess actually we want to put it right here. Well, we want it to be before we fill it with the background color though. So, okay, here we're doing the background color. Yeah, that's what I was thinking, Serge. So, I think that would be right here, right? So no, that was the wrong place. So let me try down here. Okay, now if we draw, it would help if I picked a color other than red. And yes, Mr. Pepperoni, I'm using risc-v and i3. So is that rendering above? It's actually kind of hard to tell. Let me take a close look at this. So yes, that is the proper place. So now the tricky part is figuring out how we make it yeah, it's working. So now the thing is, if we go back to our stream notes, now we actually want to do this calculation here where we figure out where to draw our lines on the screen. And then we're going to need to do an additional conversion, which is once we know where we're drawing our lines, we actually need to know, like, convert it to the -1 to 1 space that OpenGL is expecting. So let me think about this. So we have a calculation here where basically we take the screen origin in canvas space and we do mod line spacing, which is going to be something we define. So wait a minute. That's a calculation in canvas space. But then we need to know where to draw in screen space. So let me study this diagram that I drew because I don't think I'm fully remembering all this stuff. So here, let me turn off this GUI as well. Why do I have a break in the line? Do you guys see that? Oh, there. Whoa. So is that just a rendering artifact? Like, is that showing up on the screen for you guys? What's happening to the line? Oh, that's the eraser. So the eraser is drawing on top of our line. That's what's happening there. So we need to draw on top of the eraser. Ah, that makes things complicated, doesn't it? So I'm guessing the eraser doesn't I'm guessing it's not like a layer before all the strokes. Like because it would have to be on top of strokes too. Yeah, there are intrinsics for ARM popcorn. You want to look at neon. That's the equivalent of SIMD for ARM. So I'm not sure why it's using intrinsics though. So if I restrict this to only one layer, which is completely reasonable for what we're doing, we can draw the lines after the first layer mark. Okay. But are the strokes going to be there? Okay, so there is no longer intrinsics. If you do need intrinsics, this is what you want to look at. Neon. But maybe you just need to pull the latest code in popcorn. So I'm not sure I understand Surge with the layer mark thing. So let's go back to my diagram here. So I have this single layer drawn in the pancake. And so my understanding is that there's like a layer of eraser. Is that correct? So like we have strokes, but then we have like eraser. So, can you kind of explain to me, in terms of the diagram I have here, how these layer marks work? Because what I want is I want the paper to appear below the strokes, but I also want it to be above the eraser. So I'm not sure I fully understand. I'm trying to look at the code here, but I'm not seeing anything specific. Okay, well, here's eraser texture, but I'm not seeing anything about marks in the code. So if we just moved it to like right in here, because here we're doing an eraser texture, but we're doing strokes down here, it looks like. Okay, so before the line that has geoframe buffer texture, 2D extension, let's see here. Okay, so this line right here is what you're talking about. So you're saying if I do on this line right here, so line 1185. So let's give that a try. So we're going to put it right there. So now I don't have a line at all. Or rather, the line is being covered up. Later, popcorn. Also, isn't this in a for loop? So I I don't want it to draw multiple times. This is looping over everything in the clip array. And of course, I want it to actually show up too. Ah, this branch is only taken once per layer. Okay. So then the only problem is that it doesn't show up. So it's getting something is rendering on top of it. Yeah, I understood what you mean. This branch right here. So I guess the thing I'm wondering about right now is what is drawing on top of or or line, because the canvas background is already drawn. Where it is now and before the clear, after the clear. So you're saying put it back over here, like right there, but also have it right here. I will give that a try. So was that right here that we wanted it? Still no line. After the GL clear calls. Oh, okay. So you mean like right here? Okay, so now we've got a line again. But the problem still happens. The eraser still draws on top of it. I thought I did put it after both clears. There's a clear here, and then there's a clear here, right? Are there more clears somewhere else? There's a clear right here. Oh, once after each clear? That did the trick, Serge. So drawing it after each clear works. Now, do we need all three of it? So right now we have the code duplicated 3 times. So I'm going to take out this one, or I'm just going to comment it out for now and see, do we really need all of these? So this stream is pretty much just me blindly following your advice. I don't really know what's going on. So yeah, we don't need that one. So I'm gonna delete this. Yeah, now do we really need both of these? So Like, if I comment out that one, what happens? I don't understand why we would need it duplicated, basically. So yeah, we don't see it then if we just have the one. That one only shows up in the places where the eraser is. Oh, I see. So basically what we're doing is we're drawing the line on top of the eraser texture, but then we're also drawing it again on top of the layer texture. And so the net result is that we get a line regardless of the eraser. I'm pretty sure I understand. And alright, see you later, Serge. Have fun watching Rogue One. I didn't know that was even out. I kind of live under a rock, so. So there is our working line drawing routine. So we're gonna break this line drawing routine out into a function so that we can call it rather than duplicating all the code, because it's gonna get more complicated than what we have right now, obviously. So I'm going to just create like void, let's call it GPU render paper. So I'm going to put that right there. And then we're going to say GPU render paper. So render over eraser, render over layer. Okay, so that still works. So now we need to think about how we render it. So basically now we want to actually calculate where to render lines. And then we're going to start rendering multiple lines. So let's start off just by doing a loop. because we know we're going to need to do that, right? So I'm going to just throw in a define right there, and I'm going to say like line spacing, and that's going to be like so many pixels, but I don't know how many pixels. Like, we need to think about pixel conversion to the space that OpenGL is drawing in. So for now, I'm just going to say like 42. And then I'm going to go over to our canvas here and start whiteboarding out this conversion. So we're going to say like we want the screen space to OpenGL space. So screen space to OpenGL space conversion. So we're going to draw two spaces. So we have 0, 0 over here, and over here we have with height, and this is going to be screen space, and then this is going to be OpenGL space. And so this has like a point right here and a point right here, and this would be 1, 1 if I'm understanding correctly, and then this would be -1, -1. And then this, of course, is 0, 0. And this right here is 1/2 width, 1/2 height. So basically what we want to do is go from this space to this space. So basically this is a normalization, but we also need to flip the y-axis. So for the moment, let's ignore the y-axis and focus on the x-axis, 'cause that's simpler. That's just like a normalization. Whereas the y-axis, it's a normalization after a transform where we flip the axis. So to do the normalization, we're going from width height to -1, 1. So if we divide by the width height, that gives you between 0 and 1, right? So like screen points divided by width and height equals within the space 0, 1. So then if we multiply that by 2 and subtract 1, wouldn't that put it in -1 to 1 space? Because if you multiply it by 2, then you've normalized to between 0 and 2. And then if you subtract 1 from that, it's -1 to 1. So I think the conversion would be P divided by width height. So then times 2. So that would be 2p divided by width height, and then that minus 1. So this is the x conversion. Now we need to think about the y conversion. So if we just normalize it the same way we do the x, then we're going to get the same -1 to 1 space, but it's flipped on the y-axis. So mathematically, how do we flip it? That's what I'm trying to figure out. So it should be a pretty simple transform, but I'm not sure what that transform would be. Well, if it's between -1 and 1, could we just negate it? So multiply by -1, and then it would be in the space 1 to negative 1, right? But would that actually make sense for the values between? I don't think so. Like, so let's draw a number line here. So I'll put some markings down. So we're going to say this is 0. And then we're going to say this is negative 1. And then that's 1. So this is the space that we care about. I don't know what you're talking about, Kingspor. My lines are absolutely perfect. So to go, like, let's say halfway between so I'm just going to put in a marking there. This would be negative 0.5. And then this would be positive 0.5. And so we know it's correct if we multiply by negative 1. It's correct on the ends. It's correct at 0.5. It's correct at 0. What if we do negative 0.25? Well, it would flip it over here, which would just be like 0.25. So I think it actually works if we just multiply it by negative 1. Get out of here with your Casey Tron emotes. So we're going to say y conversion equals 2p over width height minus 1 times negative 1. And we can probably simplify that. But I believe we are out of time today. So we will simplify the y conversion tomorrow and start implementing multiple lines, drawing them at the correct locations and all that wonderful stuff. So thank you everyone who tuned in today, and thank you everyone who watches on the YouTube archive, which is available at risc-v. You can follow me on at HMN_risky if you want to keep up to date on the series. For example, if you want to know when we're starting on risc-v related stuff, in case you're not interested in like the Milton stuff we're doing right now, you can follow this to find out whenever it is that we start on risc-v stuff. Or if you like the Milton stuff and you just want to know when I'm streaming so that you can tune in live sometime, this is a great way to get notified of that. So that's everything for today, and stay risky, everyone.